45% protein. That is what this plant contains by dry weight. More than beef, more than eggs, more than soy on its best day. It grows on water, not in soil. It doubles its mass every 48 hours, and it fits on a fingernail. I read that number 6 months ago in a research paper and sat at my kitchen table for a long time, not moving, trying to understand how I had taught biology for 30 years and never once heard the name of the most protein-dense plant on Earth. What follows is everything I have learned since that evening. What this plant is, where it comes from, what the science actually says, and what happened when I grew it in a 5-gallon bucket on my patio. The plant is called duckweed. Lemnaceae, if the Latin matters to anyone. Most species are smaller than a lentil. Some are smaller than a grain of sand. They float on the surface of still water, ponds, ditches, slow streams, forgotten buckets behind garden sheds. If you have ever seen a pond covered in a bright green film and thought it was algae, there is a reasonable chance it was duckweed. I had seen it 100 times in my life. I pointed it out to students on field trips. I called it pond scum. I never once thought about eating it. In northern Thailand, families have been eating it for centuries. They call the smallest species kai nam, which translates to water eggs. The name alone should have been a clue. They harvest from slow-moving water with fine mesh nets, rinse it, and serve it in omelets and soups. The taste is mild, slightly nutty, clean. Nothing like what you would expect from something that grows on a pond. Grandmothers there treat it the way my grandmother treated parsley. It goes on everything, without discussion, without explanation. It is simply food. 500 million people across Southeast Asia eat various forms of duckweed regularly. That is a number large enough to make its Western invisibility genuinely strange. There are roughly 40 species across 5 genera. The two that matter most for food are Lemna minor, the common duckweed, small flat ovals about 3 to 5 millimeters across, each with a single root trailing beneath, and Wolffia, the smallest flowering plant on Earth. Wolffia has no roots at all. It looks like green dust on water. A single plant weighs about 150 micrograms. You could fit a dozen of them on a pencil eraser. Each one contains more protein per gram than a soybean. I grew Lemna because it was easier to source. Wolffia is what Thai farmers harvest and what NASA tested for space missions. Both work. Lemna is the beginner-friendly version, visible, easy to skim, forgiving of mistakes. The science arrived late, at least in the West. A researcher named Eric Lamb at Rutgers University started paying serious attention in the 2000s. He was studying plant genetics, not food security, and he noticed something odd. This tiny floating speck was producing protein at a rate that made no biological sense compared to conventional crops. When his team measured the amino acid profile, every essential amino acid was present. Complete protein. From a plant that grows on water, needs no soil, no plowing, no tractors, no irrigation systems, no pesticides. In a paper published in 2017 in Food Chemistry, researchers confirmed what Lamb had been seeing. Protein content in duckweed ranged from 20 to 45% of dry weight, depending on species and growing conditions. For context, beef sits at 26%, eggs at 13%. Soy, the plant that Western agriculture built an empire around, reaches 36% on a good harvest. NASA noticed before almost anyone else. When the agency started designing food systems for long-duration space missions, they tested every candidate they could find. Lettuce, soy, wheat, potato, spinach. The criteria were specific: high protein, fast growth, small footprint, minimum inputs, recyclable in a closed system. Duckweed won. It was not close. The Translational Research Institute for Space Health, working with the University of Colorado, published findings in 2020 confirming duckweed as the most protein-rich plant on the planet. It produces radiation-fighting antioxidants. It thrives under artificial light at half the intensity of normal sunlight. 600 grams of fresh wolfia, the smallest duckweed genus, can meet an adult astronaut's daily protein needs. The first space trial happened in 1966, decades before most Americans had heard the word superfood. Here is where the numbers lose all proportion. A study published in Science Direct in 2024 compiled yield data across multiple trials. Duckweed produces 2,080 kilograms of protein per hectare per year. Soy produces 303. Corn produces 179. That is not a marginal difference. Duckweed makes nearly 7 times more protein per unit of area than soy, and almost 12 times more than corn. One researcher summarized it in a sentence that I have read 4 times and still find difficult to absorb. A small pond surface can outproduce an entire soy field. The doubling time is part of the reason. Under favorable conditions, duckweed doubles its biomass every 48 to 72 hours. A paper in Current Biology in 2023 called it the closest plant to what researchers call a Darwin-Wallace demon, a theoretical organism that reproduces as fast as mathematically possible. Compare that to anything else in a backyard garden. A tomato plant takes 60 to 80 days from transplant to first harvest. A lettuce head takes 45 days minimum. A bean plant needs 60 days and a trellis, and prayers about the deer. Duckweed takes 48 hours to double. No soil, no transplanting, no deer. The math felt almost offensive the first time I ran it against my own garden. All those seasons of careful tending, all those dollars in seeds and compost, and a bucket of green specks outproduced it all per square foot by a margin I am embarrassed to state. The protein is not the only thing worth mentioning. Duckweed contains significant levels of calcium, iron, zinc, and B vitamins. Its fat content is low, but includes traces of omega-3 fatty acids. A paper in Food and Bioprocess Technology in 2025 measured the environmental footprint at 0.4 kilograms of CO2 equivalent per kilogram of plant material. Beef sits at 27. That is a 67-fold difference. Duckweed needs no tractors, no forest clearing for pasture, no antibiotics, no refrigerated shipping across continents. It grows where water sits still and sun falls. Those conditions exist on every continent where people live. I taught photosynthesis for 3 decades. I drew the Calvin cycle on the board every September. I explained C3, C4, and CAM pathways until I could do it in my sleep. Not once, not in a single textbook, not in a single curriculum guide, not in a single state standard did duckweed appear. The most protein-dense plant on the planet, the fastest-growing multicellular organism ever measured. The plant NASA chose for space food, and it was not in the book. That bothered me enough to ask why. The answer is not a conspiracy. It is simpler and in some ways more frustrating. Duckweed cannot be patented. It reproduces by cloning itself, splitting in half, making 2 from 1. No seeds required. No seed company sells it because there are no seeds to sell. No equipment manufacturer profits from it because it needs no equipment. No chemical company benefits because it needs no pesticides, no herbicides, no fertilizers, beyond what fish waste or diluted compost tea provides. Every middleman in the industrial food chain loses money when someone grows protein in a bucket. I spent 3 decades inside an education system funded partly by agriculture industry partnerships. The curriculum reflected the economy, not the biology. That is not malice. It is structure. And it kept me ignorant of a plant I should have known about on day 1 of my career. In early April last year, I ordered a starter culture online. $12 for a small bag of Lemna minor. It arrived in a Ziploc inside a padded envelope, looking like someone had mailed me a handful of wet confetti. I filled a 5-gallon bucket with rainwater from the barrel behind my shed, added a capful of liquid aquarium plant fertilizer I already had from years ago, and floated the duckweed on the surface. The entire setup took 4 minutes. I set the bucket on my patio where it gets morning sun and afternoon shade, pulled up a chair, and watched it do nothing. I sat there long enough to feel slightly foolish, a retired biology teacher staring at green specks in a bucket like they might perform. They did not perform. They floated. I went inside and made dinner. The performance, as it turned out, would happen while I was not watching. Day 3. I walked out with my coffee, and the surface had changed. What had been scattered green specks covering maybe 15% of the water was now a loose carpet covering about 30%. I had told students about exponential growth for decades, drawn the curve on the board, used the bacteria doubling example, watched their eyes go blank somewhere around generation 12. Standing over that bucket with coffee in hand, watching the math happen in real time on water, was different. It was like the difference between explaining a sunset to someone and watching one. I understood doubling. I had never seen it be food before. By day 5, the bucket was half covered. A dense, bright green mat, almost velvety. I touched it. Soft, slightly cool, no slime. The individual plants were so small that the surface felt like a living fabric. By the end of week 2, the bucket was fully covered, and I needed to harvest or the plants would start dying from overcrowding. They need light on the surface, and when they stack up, they shade each other out. I learned this the hard way. I went away for a long weekend in late April and came back to a bucket that looked wrong. The top layer was still green, but underneath it had turned yellow and started to smell like wet newspaper. I scooped off the dead layer, removed about 2/3 of the living plants, and the system recovered within 4 days. The lesson was obvious once I saw it. Harvest regularly, or the growth kills itself. Duckweed is a skim and repeat crop, not a set and forget one. 2 minutes every other day keeps the cycle running. Week 3 brought a different problem: filamentous algae. Long green threads appeared among the duckweed, tangling through the carpet and making harvesting messy. The cause was too much direct sunlight. I moved the bucket to a spot with morning sun and afternoon shade, and the algae retreated within a week. Duckweed outcompetes algae when light is moderate, but in blazing full sun, the algae has the advantage. I wrote that down in my notebook with a satisfaction that probably only a retired biology teacher can appreciate. Competition exclusion principle, visible in real time, in a bucket. I used a small kitchen strainer, scooped about half the surface into a bowl, rinsed it under the tap, and tasted it. Mild, clean, faintly nutty, like raw pea shoots. Nothing swampy, nothing off-putting. I was standing in my kitchen eating pond plants and trying to figure out why this felt like a secret. I offered some to my neighbor Dave, who had been skeptical of the bucket since day 1. He chewed slowly and said it tastes like salad but wetter. I chose to take that as a compliment. I dried a batch on a baking sheet in the oven at the lowest setting, about 170 degrees Fahrenheit, for 4 hours. Ground it in the coffee grinder. The resulting powder was dark green and smelled like dried seaweed. I stirred a tablespoon into a morning smoothie. No taste change. 45% protein in a powder I made from a bucket on my patio. The entire production cost, beyond the initial $12 starter, was $0. The mosquito problem was real and worth addressing directly. Any standing water in warm weather is an invitation. I solved it 2 ways. First, a piece of fine mesh screen cut to fit over the bucket, held down with a bungee cord. Air and light pass through. Mosquitoes do not. Second, and this is the better long-term answer, I added 3 small feeder goldfish from the pet store, $1.29 each. They eat mosquito larvae. They also produce waste, which fertilizes the duckweed. The fish eat some duckweed too, which keeps the population from overcrowding. The system balanced itself within a week. Fish feed duckweed. Duckweed feeds fish. Mosquitoes feed fish. I feed myself. $4 in fish solved the mosquito problem and created a closed loop I did not have to manage. I should tell this part honestly because it changed my mornings. I have 4 chickens. Before the bucket, I spent about $47 a month on feed. Not a fortune, but it adds up to over $500 a year for animals that were supposed to save me money on eggs. By midsummer, I was skimming duckweed from the bucket every other day and mixing it into the chicken feed, about a 30% replacement. The chickens ate it without hesitation. Within 2 weeks, the yolks of their eggs shifted from pale yellow to deep orange. I am not overstating this. Visitors commented on the color before I mentioned the duckweed. The orange comes from carotenoids, beta-carotene and zeaxanthin, concentrated in those tiny leaves. Same compounds that make carrots orange and egg yolks rich. 1 bucket of duckweed, skimmed every other day, replaced roughly a third of purchased chicken feed. Over a full season, that saved me close to $170. The bucket is still going. I once gave a quiz to my 9th graders where the answer to every question was the same word: photosynthesis. 12 questions, 1 answer. Most of them got it by question 3 and started grinning. The duckweed bucket reminds me of that quiz. Every question I ask about it, cost, protein, speed, sustainability, space efficiency, the answer keeps being the same plant. It does not get more complicated, it gets simpler. The practical side is simpler than most gardening I have done. Any wide, shallow container works. Storage tubs, kiddie pools, old bathtubs, even baking dishes on a windowsill for a small indoor test. Depth does not matter much because duckweed only grows on the surface. 3 inches of water is enough. Width matters more than depth. More surface area means more room to grow. Water should be free of chlorine. Rainwater is ideal. Tap water works if you leave it in an open container overnight to off-gas, or add a drop of aquarium water conditioner from any pet store. Nutrients are the one input that matters. Aquarium water is perfect. Fish waste provides nitrogen, which is what duckweed craves. If you do not have fish, dilute any balanced liquid fertilizer to about 1/5 the strength recommended on the label. A few drops of aquarium plant food each week works too. Even a single decomposing leaf dropped into the water provides enough nutrients to get started. Light needs are moderate. 6 hours of indirect brightness is the minimum. A sunny window, a shaded patio, a greenhouse corner. Direct blazing midday sun can overheat shallow water in summer, so some afternoon shade helps in hot climates. Temperature range is wide. 60 to 90 degrees Fahrenheit covers most growing conditions. Below 50, growth slows dramatically. Above 95, plants stress. Indoors, near a window, the season is year-round. I kept a small tray on my kitchen windowsill through December as a test. Growth slowed, but never stopped. In January, the coldest month here, the tray still produced a small harvest every 10 days. Not enough to feed chickens, but enough for smoothies. The biology teacher in me loved that, a visible, edible demonstration of photosynthesis running on winter light. Harvesting is the easiest part of any food production I have ever done, and I am including the time I accidentally grew 300 cherry tomatoes from a single plant I forgot to prune. Skim the surface with a fine mesh strainer or small kitchen sieve. Take half, leave half. The half you leave regenerates in 2 to 4 days, depending on conditions. Rinse what you harvest under running water. Eat it fresh, in salads, on top of rice, blended into smoothies, mixed into omelets, the way Thai grandmothers have done for generations. For storage, spread it thin on a baking sheet and dry it at 170 degrees for 3 to 4 hours, or use a food dehydrator. Grind the dried material into powder with any spice grinder. Store in a jar. The powder keeps for months and dissolves easily into liquids. Here's what the numbers look like at kitchen scale, because I know that hectare-level statistics do not mean much when you are standing on a patio with a bucket. My single 5-gallon bucket, harvested every 3 to 4 days, produced roughly a quarter pound of fresh duckweed per harvest. Dried, that becomes about 1.5 ounces of powder, approximately 12 grams of pure protein per harvest. Over a month, one bucket provided about 90 grams of supplemental protein. Not enough to live on, enough to matter, enough to replace one protein shake or one egg per day. Scale it to 4 buckets, still fitting on a small patio, and the numbers start to become meaningful. And unlike every other protein source I have tried to grow, this one requires no weeding, no transplanting, no pest control, no staking, no pruning, and about 2 minutes of attention every other day. One comparison helped me understand the scale. A hobbyist in Arizona reportedly grew more protein in a 50-gallon storage container than his neighbors produced on 2 acres of alfalfa. I cannot verify that claim independently, but the published yield data makes it plausible. 2,080 kilograms of protein per hectare from duckweed versus 303 from soy versus 179 from corn. Those numbers reshape every assumption I carried about what a small space can produce. I spent years feeling like my quarter acre was too small to matter. One bucket made me reconsider what small means. The commercial world is starting to pay attention, which is both encouraging and ironic. A company called Parabel in Florida developed a protein ingredient from duckweed called lentine. A startup in Israel called Heinemann sells wolfia as a superfood supplement under the brand name Mankai. The same plant, available for free in most temperate ponds, is now packaged and sold at premium health food prices. That trajectory, from free and ignored to branded and expensive, is familiar enough to make me smile. It happened with kale. It happened with quinoa. It will happen with duckweed. The difference is that duckweed cannot be locked behind a brand. It grows wild. It clones itself. Anyone with a bucket has access to the same biology that companies are now racing to monetize. There is a small moment I keep returning to. Late June, early morning, the light still low and cool. I walked out to check the bucket, and a wren was perched on the edge, drinking from the water between the green leaves. The duckweed carpet had a small gap where the bird's beak parted. The bird looked at me. I looked at the bird. Neither of us moved. I thought about a line I used to say in class, that the simplest organisms are often the most important ones. I said it about bacteria, about plankton, about soil microbes. I never imagined I would be saying it about something growing in a bucket next to my tomatoes. The plant is still there, still doubling, still quiet. The wren comes back most mornings. And somewhere in a Thai village, a grandmother is scooping the same green specks out of the same still water her grandmother scooped from, feeding her family the same way, without ever needing a research paper to tell her what she already knew.